to another junior algebra video. In this video we begin our introduction and our journey into quadratics. A quadratic is an expression that has the highest power of x squared. Right, let's go through some examples, see if you understand that. So we've got x squared plus 6x plus 9. Well, there's an x squared there clearly, so yes, that's a quadratic function. Here's an example, 4x minus 3. No x to the power of 2, x squared in there, so no, it's not a quadratic. That's called a linear function. Here's a rule, 9x minus 3x squared plus 2. You can see there is an x squared there. I know there is a coefficient of negative 3 out the front, but don't panic about that. It's got an x squared, so yes, that's a quadratic. And finally, 2x cubed plus 5x squared plus 6x plus 9. Well, you've probably seen the x squared there, but it's not the highest power. The highest power is actually a power of 3, x cubed. So therefore, that power of 3 makes it a cubic, not a quadratic. So that's not a quadratic function. Right, quadratics will come along in two main types of forms. The first type of form is called factored form, and it's inside two brackets like this. The other type of form we're going to look at is what we call expanded form. And we're going to learn how to take factored form and expand it, and take expanded form and put it back into factored form. So, x squared is a function that we are calling quadratic. For example, 4 squared is 16, makes a square of 4 by 4. The word quadratus is a very old-fashioned word, comes from a language called Latin for square. And that is where the word quadratic originated from. All right, so quadratics are these functions we're going to look at, and they have a x to the power of 2 in them. They produce a graph which we get called parabolas. And here's an example of a parabola. We're going to look at drawing graphs later on in our relations series. But this is what a parabola graph looks like. And they have many uses around the world, a huge number of uses. In fact, without parabolas, our technology in our world would not be where it is today. I'm going to go through a very quick snapshot of 3 or 4 things that parabolas are useful for, and hopefully you can see how important and how amazing these things are and why you need to learn about them. First and foremost, they produce satellites, and satellites are the most important part of the world, all to do with communication. I certainly, without satellites, wouldn't be able to watch my beloved Warriors live on TV. Without parabolas and quadratics, you wouldn't be able to use your time wisely on your phones and send all sorts of messages and communication to your mates. Parabolas have been used over thousands of years to produce all sorts of amazing architecture and buildings. The Eiffel Tower has a parabolic shape in one of its arches. The Sydney Harbour Bridge uses a parabolic arch. And parabolas are used in all sorts of motions, especially when things are thrown up and they come back down due to the effect of gravity. So parabolas are used in all sorts of motion type projectiles. All right, well, there's a very quick introduction to parabolas. So thanks for watching.